Welcome back then. So let's have a look at part 6. Part 6, starting around about page 228, covers inspection and testing. Now, inspection and testing is also mentioned quite extensively in the Electricity at Work regulations, and the Electricity at Work regulations clearly states that all new installations should be verified, inspected, tested before being put into service. So whilst BS 7671 is a non-statutory document, inspection and testing is mandatory. It's in the AWR. Now then, part 6 for the 18th edition has been completely renumbered. Originally we had 3 chapters, chapter 61, 62 and 63. They've now been deleted, although they still do warrant a mention in the book that they're not used. And we have 2 chapters now, chapter 64, which covers initial verification, and then chapter 65, which relates to periodic inspection and testing. A new guidance note 3 has also been issued, setting out all the new requirements in a much greater detail than the book goes into. So, regulation 641.5, for any addition or alteration to an existing installation, it shall be verified that the addition or alteration complies with the regulations and does not impair the safety of the existing installation. Now this goes right back to part 1, 132.16. And also, new for the 18th edition, we've got a requirement of doing polarity checks at the origin of an installation before it's energized. Previously we carried out polarity checks just on our circuits. Now we must check the polarity of the supply. So let's look at the old regulation first. Originally 612.6 said that a test of polarity shall be made and it shall be verified that every fuse, single pole control and protective device is connected in the line conductor and so on, and that wiring be correctly connected to socket outlets. Now the new regulation goes quite a little bit further. The new regulation 643.6 says this bit: where relevant, the polarity of the supply at the origin of the installation should be verified before the installation is energized. Where single pole switching devices are not permitted in neutral conductors, a test shall be made to verify that all such devices are connected in the line conductors only. During the polarity test, it should then be verified that, and then it goes on to mention the 3 subsections above, every fuse and single pole. So this is an additional part to the polarity. This is a polarity check at the origin of the supply. So chapter 64 deals with initial verification. Now initial verification precedes any testing. Firstly, the installation being inspected needs not to have been energized. It must be disconnected from the supply. This is necessary before any new installation work or alterations or additions. Anything can be connected to supply. We must carry out initial verification and inspection. Initial verification confirms that the equipment installed complies with the UK, a European or a suitable standard, is correctly selected, erected, and is not damaged or defective in any way that might impair safety. So the first thing we do, we have a schedule of items to be inspected. This is literally a checklist. We've got sample forms in Appendix 6 that you can look at. They set out the various questions that you should be asking as you're walking around and looking at the installation, checking tightness of terminals. Are the correct colours used? Is everything marked up correctly? Has the correct installation methods been used? Has anything been broken or damaged since it was installed? Are there any remedial works that physically need to take place? This is just a look at verification. Then we move on to 643, which covers the testing portion. Now the testing sequence, for anybody who's done any previous regs or has any testing experience, has changed for the 18th edition. The category of testing of continuity of ring final circuits has now been removed and absorbed into the continuity of conductors test, which is the first test we carry out. So looking at the list, we've got continuity conductors, insulation resistance, checking for protection by self, PELV or electrical separation, a polarity check of each circuit, protection by automatic disconnection of supply, earth electrode resistance, earth fault loop impedance, prospective fault current, additional protection, phase sequence, functional testing and verification of volt drop. Very similar to the old test sequence, but it has dropped the ring final circuits from the testing sequence. The continuity of conductors, incidentally, covers CPCs and all circuit conductors, so it's all of the cabling involved in the installation. So, continuity of conductors, 643.2. It's recommended for a continuity tester that we have a no load voltage between 4 and 24 volts, DC or AC, and must be a minimum short circuit current of not less than 200 milliamps for our tester to be accurate. There are also requirements for tester accuracy and calibration. Further details available in guidance notes. So, testing the continuity of circuit conductor test. Here's a typical ring final circuit. We would test each conductor for continuity, and we would carry out various other tests, which we're not going to go into great depth here because this is the 18th edition course and not a testing and inspecting course. But every electrician should be capable of inspecting and verifying, doing an initial verification on all of their installations. Once we've verified all of our continuity of conductors, remembering of course the Earth's CPC's bonding conductors as well, we need to then move on to the insulation resistance testing. Now this is twofold, and we first test resistance between our live conductors. Now, before testing between live conductors, it's worth bearing in mind that there may be items of sensitive equipment installed. So for things such as smoke alarms, central heating controllers, even neons that's used as indicators in isolators and switching units need to be removed or linked out. A big issue here is the modern USB sockets that have the USB connections on them. They have transformers and electronics on the back of those sockets. Testing them at 500 volts can quite often destroy them. So it may not be possible to carry out this test, in which case we would definitely just test between the live conductors and the earth. Typically, if there were sensitive items of equipment that we're unable to remove, then we should short the two live conductors, line and neutral, together and test down to earth. We're looking for minimum insulation resistance of 1 megohm on a typical install. Let's just have a look a little bit closer at insulation minimum requirements. So, minimum values of insulation resistance and test voltages as well. For SELV and PELV, we would test at 250 volts, and the minimum insulation resistance acceptable would be 0.5 megohms. All other circuits up to and including 500 volts, with the exception of course of anything below 50, SELV and PELV, should have a minimum insulation resistance of 1 meg. And above 500 volts we would test at 1000 volts, and again minimum resistance of 1 megohm. 1 megohm, very low. I would strongly recommend anything below, certainly below 5 megohms, would require some further investigation. And on a new installation, I would expect insulation to be up in the hundreds of megohms, unless there is a problem, unless there's a nail through a cable or something untoward that needs further investigation. And that's part of why we carry out the insulation test. Also, we need to check out the polarity of our final circuits and make sure that, because we've already verified the polarity of the incoming supply, but we need to verify that our circuit polarities are correct. Once we've carried out all of our dead tests, we then move on to moving in towards our live testing. First things first, we need to test the earthing arrangements, whether it be by earth electrode. And remember, we mentioned earlier on when we were talking about earth electrodes, although 1667 ohms is an acceptable value, it's recommended that the earth electrode resistance not exceed 200 ohms for stability. Also, if you recall from earlier, requires RCD protection. So we carry out a ZE test if it was the supplier's earthing system, and we would expect a ZE in line with, depending on the earthing system, of course, TNCS 0.35 ohms or TNS 0.8 ohms or less. Then we would energize the system, at which point we could then carry out things like earth loop impedance at our final points of our circuits. Now, testing at each relevant point, such as we've shown here at a socket circuit, should reveal the ZS of the circuit, which we should have been able to calculate earlier on by measuring our R1, R2 figures and adding them to the ZE, as mentioned when we were designing the circuits. So having measured our ZE and our ZS's, we can then assess prospective fault currents throughout the installation to ensure we've got the correct accessories installed. Then need to look at additional protection. So we need to look at the effectiveness provided by additional protection, such as RCDs. If we've got an RCD in the system, it needs to be tested. Now, RCD testing, our typical 61008 RCD or 61009 RCBO, when tested at 1 times, should trip in 300 milliseconds. And when tested at 5 times, should trip in less than 40 milliseconds. We need to test the RCD in the positive and negative cycle, and we'll cover that in a lot more depth in the inspection and testing course. But the actual testing of RCDs, a lot of installation testers now run a fully automatic test and carry out actually 6 tests, a half times, which shouldn't trip in both the positive and negative cycle, a 1 times, and then a 5 times. And the results of that should then be recorded on the relevant paperwork. If it's a 3-phase installation, we need to verify that phase rotation is correct. If a system involves the use of motors, it could be very important to ensure that all motors are running in the same direction. So we check out a phase sequence test. Finally, we move on to the functional testing. Now, if RCDs have been installed to provide additional fault protection, then any of those RCDs need to be verified as well. The very first test we carry out on any RCD is, of course, pressing the test button. All the test button does is test the physical operation of the RCD, checks the mechanics of it, that the spring will release. We then carry out the tests on these RCDs in the same way as we did for fault protection. We also need to check out things such as our switch gear, any control gear, controls, interlocks, and make sure they are functioning within the design parameters. Everything needs to be functionally tested, things like two-way lighting circuits, and it's good practice to go around all of our socket circuits and ensure that they're all functioning correctly as well. Anything found to be not functioning at this stage needs to be rectified before the final certificate is issued and it's handed over to the customer. Finally then, we would verify volt drop. Now, this was covered in section 525 and using appendix 4. We've calculated volt drop already when we designed our system. We worked out the minimum volt drop, and hopefully this won't be an issue, but we can carry out with our meter a simple verification of volt drop by taking readings. So that's initial verification covered. But moving onwards through the life of a system, it may begin to deteriorate. Damage may occur, equipment may start to malfunction, or indeed cables and installations may either get damaged or just simply begin to wear out. So we have to have a scheme of periodic inspection and testing put in place. And chapter 65 is the rewrite, which covers all of the relevant requirements with regards to periodic inspection and testing. Covers the general requirements, the purpose of inspection and testing, makes suggestions for frequency of inspection and testing, and the reporting procedures. Remember, this work should only be carried out by skilled persons, competent in order to look at the system and analyse and generate a report on the condition of the system. So periodic inspection and testing requires that very little dismantling takes place. We don't want to be taking things apart. We're looking at the condition of it in its current state and operation. It's good practice to loosen off a couple of socket fronts, switch fronts, and just to make a general assessment, especially if we weren't involved in the initial verification. This may be 5-10 years later. And it's always worthwhile, if we do look at 2 or 3 sockets and we find that there are issues, that we increase the sample to a larger number of sockets or accessories or outlets to look at, just to gauge the general physical condition. Now, no customer is going to let us chop holes in walls and things, so there are certain limitations. We're not going to be able to check cables that are plastered into a wall. We can, however, pop our heads up in the loft if we're in a house and have a look at any cables that are run inside the loft. It may be when they were installed there was no insulation up there. It may even be that the loft's been boarded out and the cables might have become trapped. Potential issues there that need to be looking at. So any equipment that can be inspected should be inspected during the periodic inspection and testing period. And the extent of the results needs to be written down and recorded, very similar to the initial verification form. However, on a periodic inspection form, we have a comments section where we can grade each part of the equipment based on a system of C1, C2 and C3 and an FI, which is further investigation. C1 being that danger is currently present. C2 would be that if something else happened, it could become dangerous. Whereas C3 is there along with FI, further investigation, for equipment that maybe isn't up to spec now, but was at the time, but looks like it could do with upgrading. So all of the information needs to be recorded on the relevant paperwork. Initial verification, periodic inspection. There are standard certificates, as I mentioned earlier on, samples of which all are provided in the book in Appendix 6. In Appendix 6, there are electrical installation certificates, electrical installation condition reports, and there's a small version of the installation report we call the minor installation work certificate. Now, the minor work certificate covers the alterations of the characteristics of one existing circuit. You can't use a minor works for a new circuit. That would require an installation certificate. All of these certificates should be compiled and signed by a skilled person who, as we know from definitions, is capable of perceiving the risks involved and any hazards that may arise. And the person or persons responsible for designing, constructing, inspecting, so on of any system should also be party to the certificates. So on a new installation, for instance, if the designer isn't the person putting the wires in, they should be recorded on the installation certificate as the designer. This is for traceability in the future. If something arises and there's a query about why something was designed, we've got full traceability as to who designed it, who installed it, and indeed who tested it. And all certificates should be maintained for the lifetime of the installation. It's good practice, and it also ensures that during periodic inspection we can actually assess against previous results to see if there has been deterioration in the system, just to assess how the system is performing against its previous test. So what certificates do we issue? Well, this is just a typical example here. So a new installation or a change can go on an electrical installation certificate. Now, if it doesn't require the provision of a new circuit, we can use just a minor electrical work certificate. And any alterations or additions that are not just altering one circuit go on an installation cert. Alterations or additions that don't include the provision of a new circuit, they can go on a minor works. And periodic inspection, as I said, is a completely different certificate. It has this place for the comments on it and for a write-up on the condition of the report. That's got its own certificate, the periodic inspection form. As again, all of those forms are in Appendix 6 for you to have a look at. That's a very basic outline of inspection and testing as covered in Part 6 of the book. Inspection and testing is a very in-depth subject in itself, and indeed there are separate qualifications for inspection and testing and verification. Remember though that all new installations must be designed and installed by one or more skilled persons, and the EAWR actually states that no installation can be made live until it's been inspected, verified and tested. The relevant paperwork needs to be produced as well and given to the person ordering the work. That's it for Part 6 then. I'll see you in Part 7.